The human race does not have a correct understanding of the true shape and structure of nature. So we need to go out and take a look. You, the viewer on YouTube, are my co-pilot, and we're going to go out in an imaginary spaceship and just take a look around at existence. And so we're going to go out and look at galaxies. We're going to look at the universe as a whole. We're like Isaac Asimov's ship in his great story, Fantastic Voyage. Our ship can shrink way down, smaller and smaller, and it can grow larger and larger. And so we're going to go out and just take a look at existence and see what doesn't fit, what's wrong with the picture of everything in existence and how the human race thinks it's set up right now. So let's first get in the ship, and it's got a big clear windshield, and we enlarge ourselves up to the size of a galaxy, and we go and we fly out and we look at some different spiral galaxies. We're just going to look at a bunch of different spiral galaxies. And what we see is they all have in common, they have a flat disk, they have a supermassive black hole and a big kind of bulge at the center, and then they have these spiral arms filled with billions and billions of stars or whole solar systems. And, what we want to understand is why, if we look at the Andromeda galaxy right close by, if we went out a few million light years in one direction and then billions of light years out to the edge of the universe in another direction, all of these galaxies are basically all the spiral galaxies. There are elliptical and other types of galaxies, but let's just deal with the spiral galaxies here. They're all, if the galaxies were like clay on the wheel, and with my hands here, I had forces of nature, and I could, shape and move and form. Something is doing that to get these galaxies to be so heterogeneous. They're so similar to each other. But, gravity, our theories of gravity, in no way, shape, or form can they explain all of this. And that's the only force that we know of that could act in any way on these big galaxies. If we go in our spaceship now and we go down through solar systems and down, I think the human brain is the next kind of smaller level than a solar system. Then we go down to a cellular level. If we keep going and go on down into like atoms. Now, if we're looking at an atom, this is where you could sort of say it like the forces of nature. Thinking about the strong force here and the weak force are two forces that work on the nucleus of an atom. And then you have electricity and magnetism that are working out sort of around the middle outer parts as well as the center of the atom. So here, if we have the atom on the wheel and we're looking to, and our hands have the forces of nature, the abilities of the force of nature, and we're working our atom with the force of nature, this is like it's in focus for the atomic level. It's the forces of nature fit with creating atoms the way we understand atoms to some extent. But you go back up to the galaxies, and the forces of nature are, they are not big or large scale enough to structure a galaxy or to structure a solar system or even to structure a biological cell or anything like that. In a cell, you have a nucleus, and you have this protoplasm with all the organelles sort of swimming around all over the place, and that's heterogeneous. In trees, in humans, there are differences between prokaryotes and eukaryotes and stuff like that, but there's a certain amount of similarity there, that there's something is working and shaping and causing cells to develop very similar to other cells. But it's out of the forces of nature that are in focus for atoms are out of focus for all of these other levels. And we have another big problem is the speed of light. The speed of light takes about 10 hours to go across our solar system. And that is an in focus speed for a solar system. The speed of light is sort of in focus for a solar system. Here on Earth, we're about 8 minutes from the sun at the speed of light. So the light comes out, takes about 8 minutes to get to us. So if there's a big solar storm or something, the solar storm doesn't go quite as fast as light speed, but it might take a few days or a week or something, and then we get the northern lights and all that kind of stuff. So light speed and the dynamics of what's going on in this solar system sort of really fit and work with light speed. But if you go first, let's go back down to an atom. Light speed zooms past an atom in just a fraction of a second. It's way too fast a speed. What you would need is, think how strong atoms are. We can put atoms into the metals that make up a jet engine. And they're so strong, they can withstand all the forces working on them. Well, what if there was some inner light speed that took about 10 atomic hours to cross the atom? And so that was so much slower than our light speed that it made it seem really super solid. But I'm getting ahead of myself there a little bit. So light speed crosses an atom just way too quickly. And if you go up to the galaxy again, it takes about 100,000 years for the light speed that we know of to cross a galaxy. That's so slow. Every solar system, every star system is, 5, 10, 20 light years from any other systems. That's so slow that it doesn't make much sense. At least you could say maybe there could be something there, but it doesn't make much sense. But now go up to the galactic level, and galaxies are millions of light years away from other galaxies. So the light speed is in focus. Our whole situation here, it's like what we've got is it's like we've been using the old geocentric model, saying that Earth is at the center of the solar system, and we're looking at all the orbits of the planets, and they just don't make sense. Maybe thinking that the sun going around the Earth, that was sort of an in-focus thing that sort of made sense, but looking at all the orbits of all the other planets, when you switch to the heliocentric model, now all of a sudden everything falls into place and it all makes sense. So we have the powers of the forces of nature are kind of in focus for atoms, but they're out of focus for everything else. If anything was smaller, much smaller than an atom, then it would be out of focus for that. And it's certainly out of focus for everything bigger. And the light speed is sort of in focus for a solar system, but it's out of focus for anything smaller or anything larger. So we need to find that's the problem with the model, and we need to find a new model. Okay, so that's one reason that the old model, though, what I call the static model that the scientists currently have, doesn't work. But there's another huge problem, and that is we're in our spaceship, still our imaginary spaceship, and now we're going to go up, and we're going to go until we're the same size as the whole universe. And so we're going to sit across from the universe, and here's the universe out in front of us, about the same size as we are. And we're in our ship, and we're looking through the windshield at the universe. And so now we look at each other and we say, let's make ourselves so big, so large, that this entire universe is the size of an atom, and we're going to be as big as the universe around that little universe that's now as small as an atom compared to us. Well, why can't we do that? Well, the answer would be, the forces and the speed of light and all that stuff. But we've already said, well, that doesn't make sense for all these other things. So what would stop us from just going up? What if we make a universe that's so big, our universe is the size of an atom, and then we say we want to make that bigger universe as small as an atom and keep going? What would stop us? Or let's say now we go down in size, way, way down into an atom, now down to the quark level, which is, way smaller than an atom, and then we go down inside the quarks. And let's say we get down to what the physicists call the string theory or M theory level, which in their static model is just like the smallest level. So let's say we take our ship now, we make it a little bit smaller than one of these vibrating strings, one of these M strings or whatever they call them. So it's out around us, it's vibrating out there around us. And now we say, okay, now we want to make our spaceship so small that vibrating ring is as big as the universe. We want to get that much smaller than an atom, than the quarks. We want to just go way, way down. And what's going to stop us there? Is there like a wall? Well, the wall would have to be what? Made up of atoms or something? It doesn't make sense. Existence has to be infinite. The shape of nature, the structure of nature must at least allow the potential to keep adding levels, to keep growing upward, larger and larger and larger forever, and getting smaller and smaller and smaller forever. But so right here is where we say the sentence that brings about the total complete change in the reality structure for the human race, really forever. We shed our old reality and move into an entirely new concept of existence. Because if nature is boundless, if you can go on up and up forever and go on down and down in size forever, then it must have internal boundaries. There have to be separate individual time, size, speed levels. So when the physicists say nothing can go faster than the speed of light, they're entirely correct within a given time, size, speed level. If you think of our human brain, if there's a brain time speed where it takes about 10 of these brain hours for light to cross the brain, that's probably the speed of dendrites moving through the brain. And then these axons are connecting with our outer, faster time, size, speed level. And so this is why if you put your hand on a hot burner, it can very quickly move your hand off the burner. It's what allows all the movement. We are a matrix of the cells have a very slow time speed, and then our outer world has a very fast time speed, and then our brain in the middle has a middle time speed. So it's a 3-speed matrix that works these 3 time levels together to create life. So just a couple things about this. Let's if this model is correct, does it answer some of the problems? Well, there's 2 things I think that it answers right away. First, we look out at the edges of our known universe, like 15, 16, 17 billion years from here, and we see quasars and galaxies out there. They seem to be a little bit maybe behind our local galaxies, but they do not seem to be 15 or 16 billion years behind them. If the light from a very distant galaxy way out on the edge of the universe is traveling at the galactic light speed, and then it leaves the galaxy and it speeds up, and now it's traveling at the much faster universal light speed. And so it zooms across empty space or across universal space until it hits our Milky Way galaxy, when it slows down a little bit, and then it hits our solar system and it slows down again. That distant galaxy would be a little bit behind us, maybe 1,000,000 years or 1,000,000,000 years or something, but not the full 15 billion years. And so that would explain more of the heterogeneity, the similarity of all the galaxies that are spread so far apart from each other, but all seem to sort of be more or less in a fairly similar time stage. Another thing this explains, okay, the problem for the physicists, for the astrophysicists with dark matter was that you have a galaxy and the galaxy is spinning, and the problem is the outside edges of the galaxy were spinning just much too quickly. So they came up with this concept of dark matter to try to explain some kind of extra gravity force or something that would be causing the faster spin. And that's never really held up. They've never found any proofs or anything. They never found any proofs or anything. But if a galaxy is a pool of slower galactic time swimming inside a large ocean of faster universal time, then the universal time locks onto the outside of the galaxy and pulls it around more quickly. It's spinning around more quickly because it's attached to a faster time size speed level. And it should be the same thing for a solar system. I'll bet if we look at the Oort cloud or something like that, we should find that some outer parts of the solar system, a solar system should be a pool of slower solar light speed, the light speed we're familiar with, sitting inside an ocean of the faster galactic light speed. So the model is seeming to make sense on some fronts here so far. But so next, think about this as sort of like a step pyramid where you have the biggest universal level. That's the largest and it has the fastest time size speed level. And on top of that is the galactic time size speed level. Then a solar light speed level. Then I think our brains are next. Then a cellular. Then an atomic. Those are sort of the ones we humans are familiar with. But it should keep going. Our step pyramid will keep going down with larger levels potentially forever and going up into smaller and smaller levels potentially forever. But two things about this. First, Einstein said that space-time is curved. And so another thing that explains this curvature of space-time is if you have the universe and the galactic time speed, it's inside the universe. So the universal time speed will curve around galaxies, and then galaxies will curve around, you're going inside galaxies to find the solar systems. Then you're going to go inside solar systems to find something like our human brains. Then you're going to go inside human brains or other smaller stuff to find cells. So you have this kind of curvature of everything is inside of some larger level. And the larger level is thus sort of a curved object around you. Not saying that very well, but I think you get what the point I'm trying to make there. But then another thing here is the whole thing seems very amorphous as we set it up. Is there some kind of a number or some structural component that locks this whole thing into sort of a numerical structural base that makes sense? And I think the answer is yes. I think the number 100 billion is a repeating number. Now there's still controversy on some of this, but let me start with the smallest one that I know of. We humans are made up of two sets of chromosomes, and each set of chromosomes is made up of roughly 100 billion atoms. Then our brains are made up of roughly 100 billion neurons and also about 100 billion glial cells. So we're seeing 2 of the 100 billion number again. Then you get up to our solar level, and let's come back to that for a minute. We don't know what would we associate 100 billion of with a solar system. We don't know that yet, so let's pass on that for a second. We'll come back to it. But then think about our galaxy. Most of these spiral galaxies seem to have somewhere in the neighborhood of 100 billion. I mean, women's brains supposedly are a little smaller. They have about 86 billion would be an average size brain for a woman. But for me, like, I'm about 6 feet 9 inches tall, and I wear a large hat size even for somebody my size. So my brain might have 120 billion or something neurons and glial cells. So 100 billion is an average. And another thing is we may be at a nexus of different kinds of existence. So if there are some galaxies that are just way off, they may be some other kind of life or structure or something. I mean, there's a lot to work on with this. This is, I think, but basically, there are 100 billion atoms in each of our sets of chromosomes. There are 100 billion neurons and glial cells in an adult person's brain, somewhere in that neighborhood, a little less for women. There are, we're going to get to the solar system, but there are somewhere around 100 billion solar systems or star systems inside a galaxy. And then from what we can see in the known universe, there's around 100 billion galaxies in the known universe. So I would say that is the repeating number that we could use as a start, that then a lot of this whole structural system sort of falls into place around these 100 billion unit systems. And so if we come back to a solar system, in the last video I said that if we find the correct structure of nature, we humans will see where we fit in that system. And so here, by looking at the concept of infinite existence, we see that we humans must be the 100 billion number for this solar system. So if we were to begin to move out into the solar system and start to bring the whole solar system into life and grow our population and grow our computers up to around 100, hopefully maybe 120 or so, building a male being, 120 billion human beings spread around the solar system, that's sort of a number that makes sense. I mean, looking at our human population now, we have Mars and Venus. If we cool Venus and heat Mars up and fill out into, some of the rest of the solar system, 100 billion would be about the right number, and probably about that number of computers. So by seeing nature correctly, we're starting to see our place in nature to some extent. And that concept right there, I mean, this idea that existence can have repeating levels means that we can really truly be alive. We could be building a greater brain, our computers as greater neurons, we humans as greater glial cells. And think about this. Ordinary matter makes up about 5% of everything we know of in existence. But in a human brain, in a human system, our brains make up about 5% of our human systems. And then in our human bodies, our bone structure makes up about 25% of our body, and in all of existence, dark matter is supposed to make up about 25%. So dark matter could be our greater bone structure out around us in these repeating levels. And then dark energy, our body makes up about 70% of our whole system, and dark energy, this strange sort of fluid system of dark energy, could make up our greater body with about 70% of what's supposed to be out in existence. So those numbers all match up. So there's a lot of stuff that seems to be, we're seeing a better model, and a lot of things are falling into place. So thinking about the next video here, we're going to move on to the theory of everything and come back for a minute. Let's get in the ship one last time and go down and look at atoms. We kind of got the atoms like clay on the wheel, and we have our hands as the forces, these forces of nature, and we're sort of forming the atom with the forces of nature. And the physicists look at what are these forces doing and how are they creating the atom, and we want to take that now, since that's supposed to be a repeating thing, be able to go up and look at galaxies, and we should be able to see and understand what is forming that spiral galaxy. It should be greater electricity, greater magnetism, a greater strong force and greater weak force, and all this sort of stuff. So the question is, do the physicists have the right model as they're looking at atoms and the forces and stuff, and as they're looking out cosmologically? What this comes down to is Einstein, in his general theory of relativity, came up with this idea that you have the three spatial dimensions, and then space-time is a fourth dimension that sort of curves out around the three spatial dimensions. And there's a problem with that model. And so this extends down to the atoms, it extends up into the cosmological levels. So that's where we're going to start the theory of everything. But let me just say a quick word here at the very end that just great respect to all the scientists for everything that you have figured out. All of these ideas of mine, first let me be very clear to anybody who's watching that the scientists will look at this and take these ideas and begin to chew through them and criticize and be skeptical of them and look at them. And only when the scientists start publishing articles in their journals and agreeing on things after, some of my details will be wrong. They'll do the math and figure some other things out and this and that. I'm trying to get a process started here, but I certainly recognize that it's not scientists until the scientists say that it's science. So these are just ideas, and all respect to all the standing on the shoulders of giants, just with all the great learning that you scientists have shared and made available to all the rest of us for us to be able to work on this kind of stuff. So thank you. Okay, so I'll see you in the next video for the beginning of the theory of everything. Thank you.